So for this pencast, we're going to be doing problem number 14 on assignment 1. And so this problem wants us to find the amplitude, frequency, and wavelength of the wave in this figure. And so they tell us that this is a history graph at x equals 0. And this wave is traveling left at 2.0 meters per second. And it's also worth noting that the time is in seconds and the displacement is in centimeters. So first we want to find the amplitude, and so we can see that just by looking at the max displacement here, which is 6 centimeters. So that's 6 centimeters. And now we want to find the frequency, but before we do that, we're going to have to find the period. And so the period is just the time that it takes to go one full wavelength. And so to do that, we can just measure the time from crest to crest, because that's one full wavelength. And so time will be from one crest, which is at 0.8, minus the next crest, which is at 0.2, and then you should get 0.6 seconds. Okay, and now that we have that, we can find the frequency. And since we know that t equals 1 over f, we can usually flip that equation. And so now f equals 1 over t. And so if we plug in our numbers, we get f equals 1 over 0.6. And if you solve for that, you should get f equals 1.67 hertz. Okay, so now that we have those two, we can now look for wavelength. And so for wavelength, we're just going to do the basic d equals RT equation. And so in this case, our d would be the wavelength. In this case, the r would be the velocity they gave us. And the t would be the same thing, the time. So if we plug in our numbers, we should get, oh, that wavelength sign is horrible, 2.0 meters per second times the time for one full wavelength, which is 0.6 seconds, and you should get 1.2 meters as your wavelength.